So today we're going to be talking about another kind of new thing that you guys maybe haven't seen before. Okay, we're going to talk about trigonometry ratios. Okay, and what I mean by that, okay, right? So trigonometry is like the study of triangles, right? Geometry is the study of shapes. Trigonometry is the study of triangles. And we're going to be writing these ratios, okay? Now these ratios are relationships that kind of show up in right triangles, and we utilize them, okay? So let me start here by drawing a right triangle. Okay. So draw a right triangle there. And I'll label the angles, triangle A, B, and C. Okay. And then sometimes, because we name the angles capital A, capital B, capital C, then we'll name the opposite sides from those angles. So for example, here's angle A, opposite that is this side. We'll name this side a length of lowercase a. Okay, and so that would make this side then a length of lowercase b, and this side here a length of lowercase c. Which is kind of hard to tell the difference between capital C and capital C and lowercase c, but you'll see it there. Okay. You might say, Mr. Meyer, where are the ratios? Well, here we go. So the ratios, okay, these ratios are so special that they have names, okay, and I'm not really sure where the names come from, okay, but the first ratio we're going to talk about is called sine, S-I-N-E, okay. On your calculator, you actually have a button. It's abbreviated S-I-N, so you might think that's sin, but it's actually, we say sine, okay, we say sine. Even though it says sin, we're going to say sine, okay. Thank you, Miss Katie. Okay. It looks like sin, but we say sine, okay. And so the way this works, okay, is that we can take the sine, for example, of an angle A. So we'll say sine, okay, and again, just abbreviating it, of an angle A there, and maybe I'll put the little angle symbol in there, okay. Okay. And so when we talk about the sine of angle A, okay, that's equal to a ratio. So here's the ratio. So we're basically relating an angle in the triangle to a ratio of the sides. Okay. So when I say sine of angle A, that is equal to little a, that length, over little c, that length. Okay. So sine of angle A is equal to little a over little c. Okay. And in general, it's just the opposite side, okay, of angle A over the hypotenuse of the triangle. Okay, the hypotenuse of the triangle. That was, yeah, strange noise. Oops, sorry, I'm off the screen there. There we go. Okay. And there are three ratios we're going to be talking about. So sine's one of them. Okay, that's A over C, and that's equal to the opposite side of angle A over the hypotenuse. Okay. So again, sine, it relates an angle in our right triangle here. It relates angle A to a ratio of two sides. In this case, it's the ratio of opposite side A over hypotenuse C. Okay. The other two trig ratios relate different things. So the other trig ratio we're going to call cosine. Okay, cosine, C-O-S-I-N-E, and we abbreviate that COS. Right, again, that's the button on your calculator right there. There's cosine. Okay? And the next one's going to be tan, right? It's going to be tangent is what it's short for. Tangent. I don't know why. We go sine, cosine, and then tangent. I don't know why it's like a different thing, but anyway. All right, so cosine, we can also do the cosine of angle A. All right, so the cosine of angle A that is equal to this side B over C. Okay? So sine and cosine are similar. They both have the hypotenuse of the right triangle, okay, as their denominator, but they're different because the numerators are different. Okay? Sine of angle A is the opposite side of angle A over the hypotenuse. Cosine of angle A is equal to the adjacent side. Or I should say adjacent leg over the hypotenuse. And then lastly, we have tangent of angle A. Okay? And I'll write the full word up here. Tangent is spelled T-A-N-G-E-N-T. And we abbreviate that with tan. Okay, we abbreviate that with tan. Okay? So, Melissa?
What does it say under,
Opposite side?
yeah.
Hypotenuse. 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 Okay? Anyone want to guess what this ratio is going to be? We did A over C. We did B over C. A over B, exactly right. It's going to be the last two remaining kind of pairs we can pair up. It's A over B. You could have said B over A, and actually there is a B over A. That's called cotangent, which is not one we have to worry about. Okay, but anyway, A over B, and it's the opposite side of angle A over the adjacent leg. Of angle A. Okay, so I'll let you guys finish writing that down, and I'll talk a little bit more here about it. Question?
Yeah, so there's a
All right, fair enough. So, again, what's special about these is that it's just another kind of relationship that we have in our right triangles. Notice that for this right triangle, I don't need a special angle here, right? This is not like my special right triangles where I need to have 45, 45, 90, or 30, 60, 90. I don't need that here. I don't need that, okay? I don't need a special right triangle. Just any right triangle will work here. This, again, relates angles and sides, okay? Angles and sides, okay? Why these specific relationships, right? Why not other ones? Well, the other ones do have names too. So, for example, there's a name for the one that has hypotenuse over the opposite side, and there's a name for the one that has hypotenuse over the adjacent leg, and there's a name for the one that says adjacent leg over the opposite side, but we don't worry about those for some reason. We just teach you these three here, and then in a later class you might learn about the other ones. Their names are secant, cosecant, and cotangent, okay? But you don't have to worry about those right now. Cosecant, yeah. Secant, cosecant, and cotangent. Those are like the reciprocals of those guys. Okay. One thing I also want to point out here, notice I'm very specific. I don't say adjacent side. I say adjacent leg. So if you look here, if I'm talking about angle A, if I were to say adjacent side, you could say B or C, right? Next to angle A is side B or side C. But I don't want you to be able to say side C, because side C is more specifically the hypotenuse, right? So we only use C when we say hypotenuse. When I see adjacent leg, that means we want to use the leg that's next to angle A there. So I'm taking tangent of A, so I need the adjacent leg of angle A. I need the opposite side of angle A. Okay. So now let's switch it up. What if I wanted to find the sine of angle B? Okay? What if I wanted to find the sine of angle B? Well, right, so Robbie, if I said sine of angle A was the opposite side of angle A over the hypotenuse, what would the sine of angle B be? It would be the opposite side of angle B, which is little b, over the hypotenuse, which is what? C. C, that's right. Okay. So sine of angle B is B over C. Because again, it's opposite over hypotenuse, B over C. Okay. What about the cosine of angle B? Well, cosine of angle A was the adjacent leg of angle A. So adjacent to angle A, adjacent leg would be B, right? Over the hypotenuse of C. What's the adjacent leg to angle B? A. Yeah, A over the hypotenuse C.
Okay.
Now, you have a question, yes? Yeah, we'll get to it. Fine.
Never mind. I just asked my own
All right.
He can answer his own
I know,
question.
right?
Hey, that's good. It makes my job easier. All right. But even if you want to check to see that your answer is
Well,
right.
no, it's because like when you said I was gonna say big A, but then I looked and then the A has the thing to the A, the big capital A, capital B, capital C.
They're all talking about the angles.
That's why they have that.
Exactly.
And then just the little A is just that.
Side measures. Exactly right. Exactly right. Yep. And that's very important to remember. Okay. Last thing. So tangent. Tangent. Okay. Tangent of angle A was the opposite side over the adjacent leg. So for tangent of B, it would be what? What's opposite B? B over the adjacent leg. A. So B over A. Okay, B over A. Okay. And that's all we're going to be doing with these today, I think, for the most part. Yes, we're just going to be kind of setting up the ratios, and then later we'll be looking at how we're going to use those to solve for missing parts and things. Okay. But today we're just going to be focusing on setting it up. Okay. Now, you might be thinking, Mr. Whitmire, that is a lot to remember.
Yeah, it is.
Okay. Do we really have to memorize all these relationships? Well, yes, you do. Okay, yes, you do. But I have something that can help you remember it. Okay. So if you guys remember back maybe in like elementary school or something like that, right? You learned the phrase Roy G. Biv, right?
No, I never.
You never learned Roy G. Biv? You learned PEMDAS. Okay, you learned PEMDAS. Yes. Okay. So what does PEMDAS stand for? Parentheses, exponent, multiplication, division, addition, subtraction, right? And so, rather than learning this huge long list of words, right, to learn the order of operations, you put it down into a nice shortened form. That's called a mnemonic device. Okay, I think it's spelled really weird. I think it's very Greek. I think it's mnemonic device. Okay? It's like a memory trick you use to remember certain words. And yes, I think it has an MN like that next to each other. It's really weird. It's Greek, I think. Anyway, mnemonic device. You use this to remember the orders of operation, right? Roy G. Biv are to help you remember the what? Colors of the rainbow, right? So R is red, orange, yellow, green, blue, indigo, and violet. Okay, right? As you go through the colors of the rainbow there in that order. Well, we have a mnemonic device to help you remember sine, cosine, and tangent. Okay? And it is so ka toa. Okay? It sounds like something you'd chant around a campfire, if you're dancing around a campfire or something like so ka toa, something like that. But that's the mnemonic device. Okay? My geometry teacher made a joke and said that this is Native American for he who runs with geometry book. So, I enjoyed that.
That's what it means when you said that.
He was just joking, yeah.
He said it was good.
Yeah. But I thought it was fun. Anyway, so SOHCAHTOA. So how to use this? Well, what do you think sine?
Sounds like you're trying to...
S stands for? Sine. And that's the... O stands for opposite over hypotenuse. And what's this? Cosine is adjacent leg over hypotenuse, and tangent is opposite over adjacent. Okay? SOHCAHTOA. Okay, now, don't spell it wrong, like I did. When I was in geometry, I misspelled SOHCAHTOA and I failed a test, or quiz, because I misspelled SOHCAHTOA. I think I spelled it SOHCAHTOA, like T-A-O instead of SOHCAHTOA. So make sure you spell it SOHCAHTOA, okay? Make sure you spell it correctly.
No, you're
Yeah.
maxed up with the J.
Yeah, be careful. It's SOHCAHTOA. Okay, it kind of sounds like Hawaiian or something like that too, like a Hawaiian volcano. All right, so let's find the sine, cosine, and tangent, okay, of angle S. Okay, so I'm going to give us a triangle here. We're going to find the sine, cosine, and tangent of angle S. I'm going to leave up SOHCAHTOA there to help us out. Okay, so here's our example.
You turn around, nobody's talking to you. Turn around. No, I'm fine. I'll give you the no. No, it's fine. But you need to do
Okay? So there's our triangles.
Oh, I was thinking they were trying to let you hear it.
Okay. There's our triangle. Okay? So the first thing we want to do is identify, right, angle S here in the picture. So there's angle S. Notice we don't know what the measure of angle S is. We can still do sine, cosine, and tangent with it, okay? So let's do sine of S first. So sine of angle S, right? We always take sine, cosine, and tangent of an angle. Okay. Okay, so sine, that's the so part, right? So what's opposite S?
I didn't see.
Opposite S there is 5, okay? So it's 5 over the hypotenuse of, the hypotenuse is 13. So sine of angle S is equal to 5, the ratio 5 over 13. Okay? Later, we'll learn how, once we have this set up, we'll actually be able to find the measure of angle S, what it has to be, if that's the ratio of the sine, if that's the sine ratio.
Which is
Not quite. It's not divide because we have to. This is not sine times angle S. That's good thinking though, because normally when you see something written next to each other, but it's not sine times angle S. It's sine of angle S. It's just like if you have like the square root of S, you don't like divide both sides by the square root. You have to like square it, right? You have to like do the opposite of a square root, which is to square it. Well, we have an opposite operation to sine that we can use, and it's actually on your calculator if you want to look there. It's sine inverse right there in the blue. That command. So you just press second sine, and that like does the opposite of sine.
Mr. Witt,
Yes.
do we have calculators for?
Yes, or your cell phone should also have the ability to do it too. Okay. Some of you guys, like I think Corey, did I see that you? Some of you guys have downloaded on your cell phones like emulated graphing calculators.
Yeah, that was on the board.
Okay, what's that?
That was on the board.
Oh, it's only Corey. Okay, so I can't speak to whether that's legal or not, but I mean, I'll just say that that is an option that some people have on their calculator, on their cell phone. So yes.
You can get in trouble for that?
I've never heard of anyone getting in trouble for it, but I doubt it's legal.
Oh, you're making it sound like really bad, like
No. Corey's never gotten in trouble for it. Okay, so I'm just gonna say, folks, you can literally turn your smartphone into a calculator like this. Okay, like it'll appear like this.
I'll give you download the app called Solve It.
Oh, is that free though?
It's not free.
Okay.
It's not that bad though either.
Okay.
Better than buying a $100 calculator.
Well, right. There's also, like I said though, if there's out there, I'm not saying you should do it or not. I'm just going to say it's out there. you can get like an emulated graphing calculator downloaded, so that way, and it looks exactly like this, and it does all the exact same stuff. So right, but it's illegal. That's right. But it's there.
Inverses? How do you do inverse?
I don't know if it does do that. I'm not sure if it does inverses or not. That's the point. I don't know if it does.
What is cosine? Why does it have 8? What is that one?
That's I think that's like
Not right
a different. I think so. I think it's a different thing.
All right.
Hyperbolic stuff. Yeah. I'm not sure. I'm not sure why they have that. But there are like I will say, folks, you don't need a graphing calculator. I will say there are free legal scientific calculator apps for your smartphone, and those are free, and those would have all the buttons that we need for trigonometry. Okay, so you don't need to do something illegal. You can go to just download a scientific calculator. Okay, that's all you need to worry about. Okay, so anyway, sine of angle S is 5/13. Okay, 5/13. So let's try another one here. Let's do the rest of our trig ratios. Let's do cosine of angle S. Okay, so cosine is the CAH, C-A-H. So what's the adjacent leg here? Adjacent leg, 12. Over the hypotenuse of 13. And then the last one here, tangent of angle S, okay, tangent, right, is opposite 5 over adjacent 12. Yes.
So, like, do you have to sit there and go through, like, S, T, or can you just pick, like, one letter and just go with it?
Well, because we were told specifically here to do sine, cosine, tangent of angle S, you want to use the angle S there.
But, like, you have to do, like, okay, so we did all of them with S. Then
Yeah.
what you have to do is, like, T and then go through R.
So, if you guys didn't hear, Courtney's question was, we also need to do angle T and angle R, right? Is that the basic question there? And the answer is no, not for this. However, I would like you guys to go ahead, since we're here, why don't you guys go ahead right now and tell me what the sine, just go ahead and do it on your own. What's the sine of angle R in this triangle? What's the cosine of angle R in this triangle? And then what's the tangent of angle R in this triangle? Okay, so why don't you guys go ahead, take a minute maybe, and come up with those. Again, use SOHCAHTOA to help you. Okay, and they're all going to be equal to ratios. What over what? What over what? Okay. Okay. So yeah, if you have a smartphone, please download a scientific calculator app on your smartphone. Something that's got sine, cosine, and tangent on the buttons. Okay. Because the relationship, okay, sine, if you remember back up to here, sine is opposite over hypotenuse. So, we remember that using SOHCAHTOA. So sine is opposite over hypotenuse. So sine of angle R, here's our angle R. What's the opposite? What's the opposite side of angle R?
Don't ever say that.
Too loud. What's the 5 is not opposite. 5 is touching angle R. Say again? What's the side opposite from angle R? What's the measure of it? Here's angle R. Here's our angle T, angle S. That's angle S.
I think it's the angle S.
What side? What side is opposite angle R? 12. And then what's the hypotenuse of this right triangle? 13. So 12 over 13 is your answer.
See the right angles, see how it's right? I'm confused about that. I'm trying to always go 5. I'm going to 5. I disagree with your cosine and your tangent. Hey, you didn't do it.
What I would suggest you do.
Okay, wait, we got time?
Cosine of angle R. Don't worry about trying to match the ratios to the things. Just do it. So cosine, oops, I don't know why I put the angle there twice.
Cosine is adjacent over hypotenuse, right? Oh, whatever.
Cosine of angle R. Cosine is adjacent leg over hypotenuse. So here's angle R. What's the adjacent leg? 5 over hypotenuse of 13. So it's 5 over 13. So cosine of angle R is 5 over 13. Tangent is the opposite leg over the adjacent leg. So what's opposite to angle R? Over the adjacent leg.
Don't do it.
Leg. 5. 5. All right, folks. Wait. You're good? No, wait. All right, we're going to do the first one here. All right, yes.
I don't know how I did this.
Oh, let's go over it, and then I'll take questions. Let's go over it, I'll take questions. All right, Josh. Sine of angle R, please. What'd you get?
Wait, 13, right?
Sine is opposite leg over hypotenuse. So here's R. What's the opposite side to angle R? What's this? 12 over 13, yeah. That's it. Okay, very good. All right, let's go to Tristan. Tristan, cosine of angle R there, Tristan. What would those sides be? What over what? You couldn't find it? Okay, well, Tristan, let's take a look here. Again, cosine is adjacent over hypotenuse. So here's angle R. What's the adjacent leg? That's the leg next to angle R here. Which measure? Okay, so Tristan, it's the 5. Okay, so it's 5. I'll help you out with that one. Okay, over, what's the hypotenuse of this right triangle? What's the side opposite the right angle? 13? Yeah, that's right, 13. Okay, 5 over 13. Good job, Tristan. That's right. Okay, next one. All right, let me finish these 3, and then I'll come to questions. Okay. Column W, tangent of angle R. What'd you come up with there? Remember, tangent is opposite over adjacent. So what's the opposite side to angle R? Over the over the adjacent side, sorry. So 12, and what's the adjacent leg? 5. Yeah. We don't want to use that 13, that's the hypotenuse. Okay, there it is. All right, Alex, you had a question.
Okay, yeah. For cos.
Cosine, yep.
I got when I did.
Listen up, please.
No, it was sorry, wrong one. Then I got 12 over 13.
That's right.
But then that to me that didn't make sense, whatever. So then I did 5 over 13.
That was cosine though.
Oh, I thought that was part of the thing.
So here's angle R, right? Sine of angle R. Remember, sine is always the opposite side over the hypotenuse. That's just how sine is defined to be. Why is it that way? That's just how we define it to be that way. Okay, it relates these two things. Okay, so sine opposite. So what's the side opposite angle R? The 12, right? The side length of 12. So 12 over the hypotenuse. Well, the hypotenuse is opposite the right angle there, so there it is, 13. Just 12 over 13. That's it. Do you see that okay?
Yeah.
And then cosine was 5 over 13.
So how'd you get that?
Well, because again, cosine is adjacent. So here's angle R still, the adjacent leg, because 5 and 13 are both adjacent to angle R, but only the 5 is the adjacent leg. So we want to use the 5 over the hypotenuse of 13. Okay? Now, folks, sine of angle R is equal to what trig ratio of angle S? Let me say it again. Sine of angle R is the same as what trig ratio for angle S? Cosine of angle S is the same thing as sine of angle R. Cosine of angle R is equal to what trig ratio over here? Sine. Okay? So sine of one angle, sine of R, is the same as the cosine of angle S. Cosine of angle R is the same thing as the sine of angle S. Okay? So they're kind of related. The tangents, they're just reciprocals of each other, right? They're just reciprocals. Okay.
Then how would you...
Question?
Why wouldn't it just be 5/12 or 10?
So why aren't both of these 5/12?
Yeah, because...
It has so remember, tangent, the opposite and adjacent. Well, when you change your angle, you're changing which side is opposite and which side is adjacent. If I'm talking about this angle S right here, the opposite side is here 5. The adjacent leg is then the 12 because it touches the S. Right? But if I change the angle R, now the opposite side is 12. The adjacent leg is the 5, so it switches. It flip-flops.
I think that's kind of what messes up things up.
Okay.
And then you do R.
You always want, exactly, and that's the idea is that you want to always you always want to orient yourself about that angle. Start from the angle. It's always the side opposite this angle, the adjacent leg to this angle, and the hypotenuse. Well, the hypotenuse is going to be true regardless because it's always the same. Okay. All right. So again, please try and find those a free scientific calculator app.